So let's record. There we go. So we need to find the equation of an exponential that goes through 2 points. Yesterday, we did that, but one of the points was the y-intercept. Today, we're going to talk about, well, what if neither of the points is the y-intercept? What if you're given 2 points and neither one of them is the y-intercept? It's just any 2 points, okay? So we have to do it a little differently when you don't have the y-intercept. Namely, you gotta find the y-intercept. So you'll have to work backwards to figure out what A is. So to do this, there are 4 steps that are listed here. There is also the table method, and I will show you both because some people really do prefer doing it all on a table. And if that is something that you would prefer, do it on a table, that's fine. But the equation method is substitute both of the points, x and y, into the general equation y equals a times b to the x. That will create a system. A system means 2 or more equations. That'll create 2 equations. You now have a system. We can solve the system. Specifically, I will show you how to solve this system by eliminating A. Remember, elimination is one of the ways we solve a system. And then you solve for B. Because if you eliminate A, you'll have the B left and you solve for B. And then once you have B, you're going to substitute that value B into one of the original equations, doesn't matter which one, and solve for A. And now you have A and you have B, and you write your exponential equation using your values of A and B. Okay? So we're going to take our 2 points. Neither one of them is the y-intercept, but we're going to substitute them in to y equals A times b to the x. Parentheses are optional, and it's going to be less writing if I don't write parentheses every time. So y equals a times b to the x. Key thing though is the exponent is only on the b. The exponent is not on the a. It's b to the x has an exponent, a does not have an exponent. So it's a times b to the x. Okay, I got 2 points here. My first point, 3, 48. That's the x and the y. My second point, x is 5, y is 192. Okay, and I'm going to tell you the easiest way to do this with equations is start with the point that has the higher value of x. In this case, that's going to be 0.1 for me, because notice that the x is 5 compared to 3. So this x is 5, that x is 3. I always want to start with the bigger x when I set up equations, and I will show you why you want to do it that way. Just makes it easier. You don't have to, but it does make it a lot easier. So I'm going to take y equals a times b to the x. My y is 192. My a, I don't know. My b, I don't know. But my x is 5. So my first equation, plugging in the 5 and the 192, gives me 192 equals a times b to the 5th. Okay. Now I'm going to use point number 2 to create my second equation. So I've got 48 equals a times b to the 3rd. So there is my system. A system just means more than one equation. I have 2 equations. It's a system. Okay. One of the ways we learned how to solve a system is elimination. And when we did elimination before, we added the 2 equations together to eliminate something. In this case, because there is no addition in these 2 problems, we can actually do elimination by dividing the 2 equations. I can divide 192 by 48. And then on the right side, I can divide by a b to the 3rd because it's the same as 48. So my elimination is going to be, I'm just going to divide the 2 equations. And notice what happens. The a's, boom, eliminate. Every single time this will happen, because you're just going to have the a's in the front. And when you divide them, they're gone. So Now I grab a calculator. I do 192 divided by 48, and I believe that is 4. Yes, it is. Now I have to divide the b's. B to the 5th divided by b to the 3rd. Okay? That means I've got 5 b's on top. Divided by, I've got 3 b's on the bottom. Remember, b to the 5th means 5 b's multiplied together. B to the 3rd means 3 b's multiplied together. These will cancel, these will cancel, these will cancel, and I'm left with 2 b's on the top, or b squared. Okay. The reason I wanted you to do the bigger exponent as your first equation is because you will end up with a positive exponent here. It makes things easier if your b's that are left over are on top, because then you don't have a fraction. So that's my suggestion as far as why I chose this for point 1 and the 3 when x is 3 for equation 2. It's because I wanted to have a positive exponent because it makes it easier to solve here. You can still solve it with a negative exponent, but it's just a little trickier. So please put the larger value of x on the top equation, so that way when you solve, you end up with a positive exponent. By the way, if you don't want to write this out, shortcut, subtract the exponents. 5 minus 3 leaves us 2 b's. So b squared. Now, if b squared is 4, I am going to take the square root, and b is 2. So that was steps 1 and 2. I substituted my points in, created a system, I eliminated a, and I solved for b. Okay. Number 3, I'm going to substitute b, which is now 2, into one of those equations up there at the top. I'm going to get rid of this because this was just really scratch work. Doesn't matter which equation, pick one. So either the 192 equation or the 48 equation, does not matter. So if you like to just take the one on top, then do that. 192 equals a times b to the 5th, but b is 2 to the 5th. So I just took the first equation and I changed the b to a 2. 2 to the 5th. I'm going to calculate that. 2 times 2 times 2 times 2 times 2. You're not sure what that is? Use a calculator. It is 32 though. So 2 to the 5th is 32. So now I have 192 equals 32 times a. A times 32, or 32a. Last step, I'm going to divide. So divide by 32. And a is 6. 192 divided by 32 is 6. So I now know my a and my b. So my equation will be 6 times 2 to the x power. Okay, so a times b to the x. Okay. Now I mentioned before that some people prefer to do this entire problem on a table. And that is a valid way to solve this. So if you prefer, you could set up an equation, or a table, I'm sorry, not an equation. And our 2 points are 348 and 192. There's x, there's y. So if I want to do this entire thing on a table, I'll look at my table and I say, look, my x's went from 3 to 5. 3 to 5 is a jump of 2. In other words, 5 minus 3 is 2. We jumped by 2 on the x's. That means on the y's, I have to multiply by b twice. B times b. So now I can set up my equation right here. 48 times b squared has to be 192. So 48 times b squared is 192. So there's the equation I'm going to solve. By the way, that's the same equation that I'm going to get over here after I divide by 48. So I divide both sides by 48 here. And I'm right back where I am on the other side there. B squared is 4, so B is 2. Okay, so I get the exact same value for B. So some people like to do it that way. Instead of setting up equations and dividing the equations, they just say, oh, well, how many spaces is it on the table? That tells me what kind of B I'm multiplying it by. 2 spaces, you multiply by B squared. 3 spaces, you multiply by B to the third. 10 spaces, you multiply by B to the 10th. Okay? Now, I still have to find my y-intercept. But since B is 2, I know that I can work backwards because I got to get to 0. My y-intercept is when x is 0, so I got to work backwards up the table. And I can do that since B is 2. I can work backwards by just dividing by 2. I work down the table by multiplying by 2, but I work backwards by dividing by 2. So 3, if I work backwards, the next number would be 2. And then I divide my y by 2. So this would be 24. And the next one, I divide by 2, I get 12. I divide by 2, I get 6. And there's my y-intercept. Okay, so that works too. Okay, so if you like the table method, do it that way. It makes no difference. Either way, you are understanding exactly how an exponential equation works. Okay, our second one. Find the exponential equation that passes through, and we've got an x here and a y here and an x here and a y here. I'm going to use that point first because the x is bigger. And I'm going to put them into, remember it's y equals ab to the x. That's what we're plugging into. That's the exponential. So starting with point 1, 112 equals a times b to the 5th. Point number 2 gives me 14 equals a times b to the 2nd. So I substitute in the a and the b, put the larger exponent on top because you'll end up with a positive exponent. So put the larger exponent on top. 112 divided by 14 is 8. The a's eliminate. And now I got the b's. I have 5 b's on top. I have 2 b's on the bottom. If you want to think about it this way, you can. 5 b's on top, 2 b's on the bottom. Cancel, cancel. Oh, look, 3 b's left. Or 5 minus 2 is 3. Okay? So that's how you deal with the exponents. When you divide, you can subtract exponents. So b to the 3rd is 8. So b is going to be the 3rd root of 8. And take the 3rd root of 8 on a calculator. If you don't know what it is, it's 2. Because 2 times 2 is 4 times 2 is 8. So 3 2's multiplied together is 8. And now we got to go back and figure out what a is. So take either one of these equations. It doesn't matter which one. This time I'll use the second one. Okay, 14 equals a times b squared. So 14 equals a times b squared. 14 equals a times b, which is now 2, squared. 2 squared is 4. So I end up with 14 equals 4a. Divide both sides by 4. And a is 3.5. Now we have our a and we have our b. So 3.5 times 2 raised to the x power. Okay. And again, if you don't like this, you can use a table. My 2 points are 2, 14, and 5, 112. If you decide to use the table method, it's to get from 2 to 5. That is a total of 3. 5 minus 2 is 3. I got to go 3 spaces in my table. That means over here, I have to multiply by b to the third. However many spaces is how many b's you multiply by. So here I would say 14 times b to the third equals 112. I divide by 14 and I get b to the third is 8. Take the cube root. I'm going to get b equals 2. It's the same thing. It's the same equation as right here. I mean, literally, look, 112 divided by 14. That's what we did right there. And we got the b to the third by subtracting the 5 and the 2. So we're doing the same steps. We're just setting it up differently. Now that I know that b is 2, I can work backwards by dividing by 2. I got to get to the 0 up there. So how do I do that? Well, I'm at 14. If I divide by 2, that'll get me 7. And the x will be 1. That's a 7 right there. Doesn't look like 1, but it's supposed to be a 7. Let's make it better. So divide by 2. I'm at 7. I got to divide by 2 one more time, which will give me 3.5. And there's my A. So again, if you like the table better, use the table. Okay. Next one. This one, the B and the A don't come out as pretty. So I don't want you to always think that the A and the B are going to be really nice, pretty values. Like the last 2 problems, the B was 2, which, you know, is very pretty and easy to use. But on this one, we have 2 points, 315. By the way, sometimes 315 could also be written like this. 8,85 could be written like this. So just remember that there are 2 ways to write points. You can use function notation, or you can use point notation, coordinates. So f of 3 equals 5 is the same as, or 15 is the same as 3, 15. So I'm going to do this point first because I like to put the bigger exponent on top. So I'm going to get 85 equals a times b to the 8th. That's my first point. My second point is 15 equals a times b to the 3rd. And then I'm going to divide. So 85 divided by 15 is 5.66 repeating. I'll show you on here. 85 divided by 15. Okay. This calculator tends to default to fractions. I mentioned that yesterday. However, if you don't like fractions, you can always change it to a decimal. It's 5.6 repeating. Okay. And on the other side, when I divide, the A's are going to go away. So I have 5.666 repeating equals, the A's are gone, and now my B's. 8 B's on top, 3 B's on the bottom. Shortcut, so I don't have to draw them all out, is I can subtract. You have 8 B's on top, 3 B's on the bottom. When they cancel, you will be left with 5 of them on top. That's a positive exponent, remember? On top is a positive exponent. On the bottom would be a negative exponent. That's why I suggest making the number bigger on top so you get a positive exponent. Okay, B is going to be the 5th root of 5.66 repeating. So let me do that. 5 math root. Grab that number. I'm going to take the 5th root of that. That's 1.4147. Okay, now let me see, 4, 7, we'll say 0, 4. On your Delta Math tonight, they ask you to make sure that your final answer is accurate to 2 decimal places on a lot of them. The hundredths place, that's 2 decimal places. The way to make sure that your final answer is accurate to 2 decimal places is make sure you take this out to a lot more than 2. I did 1, 2, 3, 4, 5, 6 decimal places. So that means I'm pretty sure my final answer will be accurate to 2. But if I were to round like to 1.4 and only write this much and use 1.4, my final answer will not be accurate. Okay, so just be careful, don't round too much. Okay, my A value, I take either one of those original equations, for example, 15 equals A times B to the third. It's my second equation. You can use the first or the second, doesn't matter. So I got to multiply that to the third, and I've got that number sitting right there, so I'm not even going to type it in. So when I take it to the third, I get that 2.83136. Okay. And then notice my next step is going to be to do 15 divided by that. So 15 divided by that number, and there's A. A is going to be 5.297789. So, well, now I forgot all my numbers. So when I take it to the third power, I got 2.8314. So 2.8314 times A equals 15. And then I did the division, and I got 5.297789. 2.597789. Yeah, so there's my A, there's my B. I can write the equation. This equation is called f of x, though. It's not wrong to write y equals, but since it says f of x, I'm going to call it f of x equals A times B to the x. And you see what I mean about this one not being as pretty. Didn't change the way we did it. We did it the exact same way. It's just not as pretty because of the longer decimal values. Okay. Now the last question says, find f of 12. So if you want to find f of 12, that means I got to put a 12 in here. So f of 12 is going to be 2.597789 times 1.414704 raised to the 12th power. My calculator is nice. Not all of you guys have the ability to cut and paste, but okay, I wrote the wrong value for A, didn't I? It's supposed to be 5.2977. I flipped the 5 and the 2. So let me fix that. I was doing it by memory, and I did not remember it very well. So it was supposed to be 5.29. So you guys have the advantage of your calculator is not on an iPad where if you want to write things down, your calculator goes away. So you can read it right off your calculator. Okay, so let's put the calculator back on here. So my A is the 5.297789. So I'm going to copy that value, parentheses. I'm going to take my 1.4 value from up there, and then I'm going to raise that to the 12th power. So it is kind of nice to be able to just copy and paste stuff. So to 2 decimal places, this would be 340.47. Okay, and the to 2 decimal places just depends when you're doing the Delta Math. If it says the hundredths place, that means 2 decimal places. Tenths is 1 decimal place. Thousandths is 3 decimal places. So just read the instructions, and to make sure that your final answer is accurate, just make sure all the numbers you use before you're done, you take it out to a lot of decimal places, like 5 or 6 decimal places. Okay, if you round too much and type in rounded numbers into your calculator, your final answer will be inaccurate. And since it's a computer program, if you're off, it'll mark you wrong, even though everything you did was correct. It was just an accuracy issue on your rounding. Okay, I want to do one more example, not the whole way through, but I want to show you what would happen if one of your x's was negative. Oh, let's see. So what if we had these 2 points? So here's a point, here's a point. Now remember, the number in the parentheses is the x, this number is the y. So -2, 6 is the first point, and over here, 6, 54 is my second point. But I'm going to do this one first in my equation and that one second. Okay, so when I do f of 6 equals 54 first, I'm going to get 54 equals a times b to the 6, because I like having the bigger exponent on top. My other point is going to be 6 equals a times b to the -2. And the reason I want to do this example is, look, there's a negative exponent. But do not freak out. My a's still cancel. My 54 divided by 6 is 9. But let's talk about that negative exponent. B to the 6 means 6 b's on top. B to the -2 on the bottom. Remember that a negative exponent means cross it off and move it to the opposite location. So b to the -2 means there are 2 b's, but they're actually on top. So if you take a look total here, we now have 8 b's multiplied together. So this is going to be b to the 8th. Does subtracting still work? Yes. 6 take away -2 is 8. So you can still subtract, because 6 take away -2 is +8. You're taking away a negative, which really means you're adding. So if you see a negative number as one of the exponents, you can think of it as 2 different ways. You can bring it up to the top, or you can still subtract the exponents. So if I was going to find b now, my b would be the 8th root of 9, and I'm not going to finish this because now it's just like any of the other problems. Okay? But I did want to address what happens when one of your x's is negative, and really it doesn't change how you do it. So if you just say, I want to subtract the exponents, do it, subtract the exponents. Or if you want to say, oh, well, what does the -2 mean? It means that there are 2 b's, but they're on the top. That's what the negative exponent means. It tells you how many there are, but it says put them in the opposite location. So when they're on the bottom with a negative exponent, just move them to the top. Okay, so either way, you end up with b to the 8th. Okay, so those of you guys online, let's see where we're at here. It's 10, and class is done today at, let me look at the schedule. I think we are done at 10:35. I will double check that, but I believe that is where we're at. So modified bell schedule. I'm gonna